Math 1332, Chapter 3, Symbolic Logic, Section 4, Logical Arguments. Video 6, Common Valid Argument Forms, the Law of Syllogism. Now, I think this is a logical argument that you may intuitively know already, but we're about to find out. And if not, then we'll refine it, and I'll say this is what you need to know. All right, so let's start with the setup. Can you draw a conclusion from these premises? Premise number 1, if it is raining, then I will open my umbrella. I'm going to go ahead and highlight simple statements using the same color when they occur again. Premise number 2, if I open my umbrella, then I will stay dry. Well, there's a new simple statement, so we need a new color. All right, can you draw a conclusion? If it is raining, then I will open my umbrella. If I open my umbrella, then I will stay dry. If you're having trouble drawing a conclusion, it's because the conclusion that you can draw from this argument is not a simple statement. Because the conclusion that you can draw is another conditional. Therefore, if it is raining, then I will stay dry. Now look at it again. If it's raining, then I will open my umbrella. If I open my umbrella, then I will stay dry. Therefore, if it's raining, then I will stay dry. But I want you to notice the location. Excuse me, I need to fix something real quick. This yellow is a little bit too wide because the if is not part of the antecedent. The if tells you where to find the antecedent. The antecedent is the simple statement that follows it. But I want you to notice the structure of the simple statements here. It is raining. I will open my umbrella. I will stay dry. Because in the conclusion of the argument, we have another conditional that has the same antecedent as the first premise and the same consequent as the second premise. I almost see this as dominoes. Yeah, I said dominoes. And if you're wondering what do I mean by I almost see this as dominoes, allow me to draw a little picture real quick of a couple of dominoes. Now, if you've played dominoes before, then you've probably played a version of dominoes where you have to match the end of one domino with the end of another domino. I know if there's doubles and spinners, it's different, or even if you're playing something different like 42, then you don't make them match at all. But I see conditionals as dominoes. What do I mean by that? Well, each conditional has an antecedent and a consequent, and I see those as two halves of a domino. Two halves of a domino. And this particular argument form says if the end of one domino, let's do this. I'm going to use the same colors I used to highlight up there. If the end of one domino matches the beginning of another domino, so these two dominoes would represent my two premises. This is premise 1, excuse me. This is premise 1, and this is premise 2. But if the end of one domino matches the beginning of the next, if the consequent of the first premise matches the antecedent of the second, then you can form a new conditional by connecting the dominoes and ignoring the stuff in the middle. And that's what the conclusion would be. So that's how I see this particular argument form, as matching dominoes end to end, and then drawing a conclusion that says if I start at the beginning of the first domino, then I conclude the consequent at the end of the last domino. This is actually a valid conclusion. This is the first common argument form we've encountered where the conclusion is not a simple statement. This argument form is known as the Law of Syllogism. It actually has two names. We're going to call it the Law of Syllogism. In other areas, it might be known as the Law of Transitivity, And if you know what the transitive property is, then it makes perfect sense. In numbers, the transitive property says if A equals B and B equals C, then A equals C. For example, if I'm the same age as George and George is the same age as Lisa, then I'm the same age as Lisa. Basically, the law of transitivity says you have this string of things that are equal, and so you conclude that the very first thing equals the very last thing. In logic, it's you have a string of conditionals, the very first antecedent. Excuse me, when I say a string of conditionals, I mean the end of one conditional matches the beginning of the next. And if you have a string of them connected that way, then the law of syllogism says you can make a new conditional by starting with the first antecedent and ending with the last consequent. So what I'm kind of implying here is that this works for more than two premises. For example, if I had a third premise that said, if I stay dry, then I will be happy, then I can conclude if it is raining, then I will be happy. All right. So here's our common argument form number 3, the law of syllogism. Symbolically, it looks like this. Your first premise is a conditional with an antecedent and a consequent. That's what conditionals have. Your second premise is another conditional whose antecedent matches the first consequent, and it has a second consequent. Then the conclusion is you can make a new conditional that begins with the original antecedent and ends with the last consequent. In words, descriptively, it looks like this. If your first premise is a conditional where it has some antecedent and ends with some first consequent, first because there will be a second. Then your second premise is another conditional that begins with where the previous one ended and has a second different consequent. Then you can make a new conditional with the original antecedent, but the final consequent. It's almost like eliminating the middleman. It's almost like you're saying, you know what? We don't have to stop here. We can just say if the antecedent, then the second consequent. So let's take a look at a couple of examples real quick. The first one, we're going to draw a conclusion. Now, this is the first example I've done lately where the problem was actually to draw a conclusion, not to determine if the argument was valid. But it's nice to know how to draw correct conclusions. It's also nice to know how to process if somebody's conclusions are correct using either a truth table or a common argument form. All right, so for this example, we're given two conditionals, which is a dead giveaway. It's the law of syllogisms. If I have to go visit your teacher one more time, then you'll be grounded for a week. And if you're grounded for a week, then you can't go to the football game on Friday. Two conditionals. And more importantly, the end of the first conditional, the first consequent, matches the antecedent of the next conditional. If we were to write it in the correct form, our first premise is, if I have to go visit your teacher one more time, then you'll be grounded for a week. And your second premise is, if you're grounded for a week, then you can't go to the football game on Friday. This has the setup for the law of syllogisms. The first premise is a conditional with its antecedent and its consequent. But the second premise is another conditional whose antecedent matches the previous consequent and has a new second consequent. So if we want to draw a conclusion without being told, is this conclusion valid? This is the setup for the law of syllogisms. If you go back over here, remember when I said these guys kind of cancel each other and you're left with the if first antecedent, then second consequent? That's exactly what's happening here. This matches that, and they sort of cancel, and so we're left with if this, then that. So it probably won't surprise you. Okay, maybe it will. I was going to say it won't surprise you that that's the conclusion that I have typed here, but now I remember why I didn't type it in the first place. The reason I didn't type it is I want to show you a, I want to show you a visual on what's going on here. Now you've already seen the matching colors in the grid. Sorry for the interruption. I had a phone call I had to take, but I think I know where my train of thought was. I was about to explain why I did not originally have the conclusion of this argument typed and covered up with like a white box or something. It's because I wanted to go in and show you what I literally think, what I visualize when I see the law of syllogisms. And to do that, I need to go inside this text box. What I literally see when I have the two premise set up for the law of syllogisms, one conditional followed by another, where the end of the first conditional matches the beginning of the second, is I see words moving around. My conclusion is going to start with the beginning of the first premise and end with the end of the second premise. And it looks something like that. So that the antecedent of the conclusion matches the antecedent of the first premise, and the consequent of the conclusion matches the consequent of the second premise. Again, it's almost like we have this canceling effect here, and we just smush the two statements together to make a new premise, a new conditional. I want to take a look at one more example that looks very intimidating. Determine if the following argument is valid. Now, this is loaded with all kinds of stuff. It's got P's, it's got Q's, it's got disjunctions, it's got conditionals, it's got negations all over the place. It's got a couple of biconditionals. But the one thing about this example that jumps out at me is that the first premise is a conditional, the second premise is a conditional, and the conclusion is a conditional. Whenever both premises and the conclusion are conditionals, it makes me wonder, is this the law of syllogisms? And the law of syllogisms has a very unique structure in terms of antecedents and consequences matching each other. So let me start with the first premise and highlight its antecedent, which is the part to the left of the conditional arrow, and see if that's anywhere else, and it happens to be right here. Now let's look at the consequent of the, cat, quit chewing this cord. Let's look at the consequent of the first premise and see if it shows up anywhere else. Well, P disjunction negation Q occurs right here. And you can probably tell now by the parts that aren't highlighted that the consequent of the second premise matches the consequent of the conclusion. This is the law of syllogisms, even though the antecedent and the consequence of our conditionals are very loaded with a bunch of symbols. The beginning of the first premise, the beginning of the first premise matches the beginning of the conclusion. The end of the second premise matches the end of the conclusion. Color-wise, this is the exact same thing as that, which is the exact same thing as that. It's all about structure and not necessarily the pieces on either side of an individual conditional. It's just how those pieces are related to each other. So yes, this is valid by the law of syllogism. One second. Syllogism, singular. I keep wanting to make it plural for some reason. All right, so just to summarize and in this video, the law of syllogism says the following is a valid argument form. Symbolically, your first premise is a conditional. Your second premise is also a conditional, but the beginning of it matches the end of the previous one. And your conclusion is another conditional where it matches, and we're going to shrink this down here for a second, where the beginning of the first premise matches the beginning of the conclusion. and the end of the second premise matches the end of the conclusion. If you wanted to use the same colors I used before, it would look a little something like this. P points to Q, Q points to R. Our conclusion, that's not the right color. Our conclusion is P points to R. Or in descriptive form, if you have one antecedent pointing to a pointing to a consequent, but then you have that consequent pointing to a second consequent, then the law of syllogism says you can make a new conditional by saying if the first antecedent, then the second consequent.